Good morning, good afternoon, good evening, depending on where you're watching from. We have been talking about chemistry practicals, and we have been discussing on volumetric analysis. So volumetric analysis, like I told you before, is one of the common questions we will normally witness in chemistry exams, especially Waec, SSC exams, and it has been a common question. This question is always every year, and I want to guide you. I want to give you some hints on volumetric analysis. One, the use of pipette. The one thing you need to do is that whenever you want to use the pipette, you have to clean, wash your pipette with soap and tap water. Also, try to maintain the burette in the same way. Conical flags, also the indicators. I have to have the get the good knowledge of the indicator and the procedure for titration. You have to also know them. But I don't want to go into that area until like I told you before, we need to go to lab to test some of these practicals, and these practicals are always there to guide you. Now, just like you can see from this specimen recording, first of all, you after doing a titration, you have to take notice of these things: the volume of base use, like the volume of pipette, the volume of pipette use. You have to take notice of that. I told you before that we have 25 centimeter quick pipette and 20 centimeter pipette, so the one you use need to take no record of that. The indicator use is, we have so many indicators, so you have to specify the one we use, either metal range or the ones you know that is being the one that is given in the question. You have to identify them. Now look at those readings you see there. The readings you are seeing here, you can see that these are called rough titration, the initial reading and the final reading. Like this reading, I will explain them when I go to lab with my students. You will understand how we got these readings, but I'm just trying to guide you first so that you understand this, the way of solving these problems. Not all about the reading, is all you solving the problem. Reading is very, very important, but solving the problem is also one of the main factors. It's one of the challenges students have in the students have always encountered in this exam. But now let's go into this. Now you have that I just have a, I told you that in rough reading we don't accept the rough readings in terms of checking the average volume of acids. So first of all, we did a rough titration. Then the bullet reading was at 0.00, and that is the bullet reading. At initially the acid was fit to 0.00. So after titration, after titrating you, the reading at that point, at the first rough reading there, you is 30.00, sorry, 30.50 or 30.50. Now this rough reading, we don't use it to check everybody. We call it rough to test the titration procedures. We use it to test the titration procedures. Now the first reading is, now you are starting, when you talk about the first reading or the first titration, that means you are not starting the titration properly. You are now trying to carry out the practical. Any reading you get from that place is a valid reading. Why the rough reading is not a valid reading? We don't value it. It's not a valid one. So for this one now is a valid reading. Any reading you call first, second, third, or fourth titration is called a valid reading. Now look at the reading. Now initially we have to feed the acid into the burette to the point of 0.00, and after the titration we had that we observed that the where the end point, where we got the endpoint, the reading, that is the number of volumes, the volume achieved at that point is 31.00. After that again, we now feed the acid back to, at least we did not get it to the 0.00 again, we will stop at 10. That is the initial reading, we stop at 10.00. After iteration we got 42.00. Now how do you get the volume of acid used? The volume of acid used is when you subtract the final reading minus to from the, sorry, subtract the final reading from the initial reading, you get this. So that means 30.50 minus 0.00, you're going to get 30.50. Now 31.00 minus 0.0, you also got this value. 42 points this minus this, we get this. So that is how we got the volume of acid used, or called the titers. Now every volume of acid used, we call it VA, is equals to, I told you that you don't add this rough reading in times of calculation. You always take the first reading and the second reading. So this plus this divided by the number of titrations that is valid. The valid titration is 1 and 2. First titration, second titration. So these are the valid titration, so it is only 2. That is why we say this plus the divided by the number of titration, valid titration. So this is the volume of acid. There are things you need to understand whenever you are embarking on titration, sorry, volumetric analysis equation problems. Now, unit must be indicated on titers, just like you have seen that the units are here. Look at the units. These are the units. After solving, you must observe the units. Bullet reading should be uniformly read to second decimal place and so be recorded. So you can see that these are in second decimal places. You can see 1, 2. It's not that. So if some students will go as far as, because of maybe not understanding the principle that is involved, they will just feel maybe 30, you write 30. If you write 30 like this or like this, it will mark it 0. So what you need to do is, if the reading is 30, you say 30.00. If the reading is 30.5, say 30.50. So in two decimal places, you must observe that. So when you watch this reading, everything I'm doing are into the least value you can obtain is two decimal places. You can extend, but two decimal places is the uniformity that we normally or this thing recognized. Now, reading to be average should not differ by more than 20. That means when you read the first reading, that is a readings to be average should not look at that word, should not reading to the average should not differ. Yes, should not. Understand what should not to the averaged should not differ by more than, meaning that if the first reading is 30.50, the next one should not extend to 30 point, let's say 80. This is error. But if, because it's not, now when the minority is 30.50, it's going to give us 0. This is 0.30. So the difference is more than 20. Is more than 20. So this is not valid. But at least when you have 30.50, the next one should at least be either 30.60 or 30.70 or 29.50 or 29.00. So the difference is either you have let's say you are having something let's say 29 point is okay. At least sometimes you can also have this. The difference should not also extend more than 1 point something, some valuable this thing. So there is like, let's say just put it in that way, that it should not be different of 0.20 this centimeter. That means it will not extend. So at that note, you just take the note of that. Leave this one first for now. We are going to explain how to manage a reading of this nature. I'm going to explain this later. So let's assume that you have 30.50 and the next one should be at least 30.60 or 30.70, just like that, or 30.40, just like that. So the difference should not be as much the more than the what you have as initial reading. So when you have that, you start having error in calculation. Now in calculation in acid-base titration, the most commonly observed type of chemical reaction involved in titration is the acid-base neutralization reaction. And what is neutralization reaction in acid-base? Neutralization reaction is the reaction between acid and base to form salt and water. So when acid react with base, that's what is called, the acid has been neutralized. That is why I call it neutralization reaction. It is only the base that have the power to neutralize an acid. So when the acid reacts with the base, they form what is called salt and water, and that is called neutralization reaction. So this reaction is always common in terms of titration. And other forms of the titration that we have observed is the oxidation and reduction reaction, where you have, we call it the redox reaction, where you have something like this potassium magnet and other things that are involved. You reacting them with some ions, so you know what I'm talking about, the redox reaction. Now in solving this problem, also to cope with calculation in titration, a good knowledge of the following should be what acknowledge. One, balancing of chemical equation is very, very important. If you don't know how to balance chemical equation, you have problem in terms of trying to relate your acid and mode. So acid, the number of acid and number of base in terms of their moles. So it will give you a lot of problems determining your A, Na, and what Mb. So when you balance your chemical equation, because that is only where you get the Na and Mb, when you balance the chemical equation properly. So that is one. You need to know what is called the mole concept. The mole concept is for you to understand the number of mole in acid and the number of mole in the this. And then the last and not the least is the unit of volumes, concentration, and moles. You must understand that we have different units of concentration and mole. Like when we talk about concentration, we have what is called the concentration, mass concentration. We have the mass concentration, mass concentration all over molar mass in this note, in the molar mass. So in this area, you have on this note, you have that the mass concentration is given in gram per mole, gram per mole, I think, gram per mole. Yes, gram per mole. Are you sure? No, that is not. It's given in gram per dm cube. Sorry, gram per dm cube, and this one is given in gram per mole, gram per mole. So in that note, on that note, we cancel out the grams. We have to observe that we are having mole per dm cube. So that is how to check this. So I will advise you to work on this little explanation on how to get the right values. Now let me explain the, let me just